This is chapter 5 of this course, and the chapter name exponential and logarithmic function. But in this video I am going to discuss only exponential function. And first you need to know what is an exponent. For example, in this expression a to the power n is called exponent or index. N is called exponent or index, and A is called base. A is called base. So the question is where this expression comes from. If you multiply a 2 times, then you will get a square. If you multiply a 3 times, then you will get a cube. Similarly, if you multiply a n times, then you will get a to the power n. And that's why here n is called exponent and a is called base. And exponent can be a fraction, which is called fractional indices or exponent. Fractional indices or fractional exponents. For example, this symbol we use as a square root. We say square root of a, or this one actually a to the power half. Square root means a to the power half. Here half is the exponent. So exponent can be a fraction. And this one we say cubic root of a. If you put 3 here, then it is called cubic root of a to the power 1 by 3. If you don't put any number here, it means there is 2. And similarly, this one, if you put n here, then this is called nth root, a to the power 1 by n. So this is called nth root, or more accurately we should say nth root radical. Nth root radical, radical. So this one you can say square root radical, this one you can say cubic root radical, is this one you can say nth root radical, but simply we can say square root, cubic root, fourth root, fifth root, nth root, and so on. If you put, for example, cubic root of a square, then this the indices or the index will be 2 by 3, a to the power 2 by 3. And if you put fifth root on a cube, then it will be a to the power 5 will be in the denominator, so 3 by 5. Here 3 by 5 is called index or exponent, and a is the base. And now the next question is, what is an exponential function? We understand that in this expression n is called exponent and b is called base. Exponent can be a fraction like this, fourth root of a to the power 3, which is equal to a to the power 3 by 4. Now what is an exponential function? Like we know, this is an algebraic function because each value of input variable x, there is a single value of output variable y. X is called input variable, we know, or independent variable, and y is called output variable or dependent variable. So here for a single x you will get single y, therefore this is a function algebraic function. If you write y equal to, for example, let's say sine of x, we know this is a trigonometric function. Say this is called inverse trigonometric function. So similarly, what is an exponential function? In this chapter, in this lecture, or in this video, we want to know exponential function. What is an exponential function? As we know, y equal to 2x plus 5, y equal to x plus 5. I said this is an algebraic function. This one we can say, and we also know y is a function of x. Here y is in terms of x, so we can say y is a function of x. So this algebraic function we can also write in this form, fx equal 2x plus 5, since fx equal y. So this is an algebraic function. Similarly, what will be an exponential function? A function of this form, fx equal a to the power x, where a is the base, we know, and x is the exponent. And here exponent will varies. In the exponential function, exponent will varies over all real numbers, but a is fixed. Base a is fixed. Then it is called an exponential function. However, without this condition, it is not an exponential function. Which condition? Base should be always positive, but not equal to 1. Base should not be equal to 1. Why? You see, if y equal 1 to the power x, then it will be 1. So we know y equal to 1 is a constant function. This is not an exponential function. Therefore, the restriction on a is this: a should be always positive but not equal to 1. So we understand that y equal a to the power x, where a positive and a not equal to 1 is called an exponential function, where x will varies, exponent x will varies over all real numbers. However, a is fixed, b is fixed. For example, y equal 2 to the power x. This is an exponential function. Or y equal 5 to the power x. For all x belongs to R. X belongs to R. Real number. For any real number x. And here x varies over all real number. So y equal to 5 to the power x is an exponential function. And now to solve some mathematical problems, you need to know some rules or laws or properties of exponent. Rules, laws or properties of exponents. When a and b is, we consider a and b as base, then the properties of logarithm is this. First one, we know something to the power 0 equal to 1. For example, 2 to the power 0 equal to 1, or 5 to the power 0 equal to 1. Any number, any real number to the power 0 will be equal to 1. 100 to the power 0, which is equal to 1. So this is the first properties. And second properties, when you are multiplying to exponential function, or like this, you see a to the power 2 into a to the power 3, then it will be a to the power 2 plus 3, which is a to the power 5. So in the case of multiplication, the exponent will, you need to add the exponent. তাহলে কি হবে, গুণের ক্ষেত্রে পাওয়ার যোগ হবে, গুণের ক্ষেত্রে এক্সপোনেন্টগুলো যোগ হবে, a to the power x into a to the power y equal a to the power x plus y, এবং ভাগের ক্ষেত্রে পাওয়ার বিয়োগ হবে a to the power x divided by a to the power x divided by a to the power y, which is a to the power x minus y. Something like a, তুমি a কমন নিতে পারো, এরকম এখানে a টু দি পাওয়ার x, a টু দি পাওয়ার x, তাহলে পাওয়ার একটা থেকে আরেকটা বিয়োগ হবে ভাগের ক্ষেত্রে, কিন্তু গুণের ক্ষেত্রে পাওয়ার কি হবে, যোগ হবে, a to the power x plus y. For example, a to the power 5 divided by a to the power 3 is equal a square. And power and power will be multiplied each other. For example, a to the power x whole to the power y equal a to the power xy. And you see a to the power 4 whole to the power 5, which is equal a to the power 20. And another example, let's say a to the power 4 whole to the power 5 whole to the power 2. This equal a to the power 4 times 5, 20 times 2, 40, a to the power 40. So all power you need to multiply. যত পাওয়ারে থাকুক না কেন সবগুলাই গুণ হবে। And number 5, you see the power you can distribute when a and b are in product form. A to the a times b whole to the power x is equal a to the power x into b to the power x. For example, ab whole to the power 5 equal a to the power 5 into b to the power 5, or ab whole to the power 2 is equal a square b square, or ab whole to the power 3 is equal a cube into b cube. And in the division case, this is also true. A by b whole to the power x equal a to the power x by b to the power x. For example, a by b whole to the power 6, which is equal a to the power 6 divided by b to the power 6. But note that in addition case, a plus b whole to the power 2, or subtraction case, a minus b whole to the power 2, which is not equal a square plus b square, which is not equal a square minus b square. In the case of multiplication and division, you can distribute the power, but in the case of addition and subtraction, the distribution of power is not enough. In addition, there is another term we know, which is 2ab. In that case, it will be equal. If you add another term, a square plus b square minus 2ab, then it is true, this is equal. Number 7, পাওয়ারটাকে যদি তুমি উপরের থেকে নিচে নিয়ে আসো, then the sign of the preceding sign of this power will change. For example, a to the power minus x will be equal to 1 by a to the power x. A to the power minus 5 is equal 1 by a to the power 5. A to the power minus 5 is equal 1 by a to the power 5. And note also that a to the power 5 is equal 1 by a to the power minus 5. Denominator, this one is in the numerator, but if you want to put a to the power 5 in the denominator, the preceding sign will change. If it is plus minus here, it will be plus. If it is plus here, then it will be minus here. And a to the power minus 1 is equal similarly 1 by a to the power minus 2, for example, 1 by a square, a to the power minus 3 is equal 1 by a to the power 3, or a to the power 4 is equal 1 by a to the power minus 4. Number 8, property 8, when base are same, you see a to the power x equal a to the power y, then you can write, or you can equate their power, or indices. X will be equal to y. For example, 5 to the power x if equal to 5 to the power 2, then we can write x equal to 2. Since base equal, then you can write x equal 2. Similarly, when power will be equal, power will be same, a to the power x, b to the power x, or index is same, then you can equate their base. A to the power x, a to b to the power x implies a equal to b. For example, x to the power y, 5 to the power y. So you can informally cancel y and you can write x equal to 5. So let me say it again, যখন বেস সমান হবে তুমি পাওয়ার ইকুয়াল লিখতে পারো, আবার যখন পাওয়ার সমান হবে তুমি বেসকে ইকুয়াল আকারে লিখতে পারো। So let me now discuss the graph of exponential function. Sometimes it is important to know the graph of an exponential function. And here we want to discuss y equal 2 to the power x. So you can graph it point by point. For example, when let's say this is x and y. When x equal to 0, then y will be what? 2 to the power 0, which is 1. And when x equal to 1, y will be 2 to the power 1, which is 2. When x equal to 2, y will be 2 to the power 2, which is 4. When x equal to 3, y will be 2 to the power 3, which is 8. And now let us consider the negative x. When x equal to negative 1, y will be 2 to the power negative 1, which is 1/2. When x equal to negative 2, y will be 2 to the power negative 2, which is 1/4. And when x equal negative 3, y will be 2 to the power negative 3, which is 1/8. 2 to the power negative 3, which is 1/8. So now let us plot those points. The first point 0, 1. 0, 1 is this point, we know. This is the origin, 0. So when x equal to 0, y is equal to 1, this point. And second point 1, 2. When x equal to 1, y is equal to 2, this point. When x equal to 2, y equal to 4, this point. When x equal to 3, y equal 8, which is this point. And so on. The graph will continue up to infinity. And when x equal to negative 1, y is equal positive half. When x equal to negative 2, y positive 1/4, which is this point. And when x equal to negative 3, y equal positive 1/8, and so on. So this is the x-axis, and the two lines will meet each other at infinity, because when x equal negative infinity, y will be 2 to the power negative infinity, which is equal 1/2 to the power infinity, which is equal 1/infinity, which is equal 0. So when x equal to negative infinity, y will be 0. Y will meet to the x-axis at negative infinity. And when x goes to infinity, y will be again infinity. So this is the graph of an exponential function, y equal 2 to the power x. Now let me also discuss some other cases. For example, I said when b is positive, when b equal to 1, base equal to 1 in this function y equal b to the power x, when b equal to 1, then it will no longer be an exponential function. It will be a constant function, which is this red line. But when b greater than 1, and we know b should be positive, b should be always positive, but not equal to 1. not equal to 1. So what happened when b positive? If b positive, then you see, if your b is 2, then we already discussed this graph, this one, and when b equal to 3, then the graph will be more steep in the first quadrant, and when b equal to, for example, 10, it will be more steep in the first quadrant. But when b is less than 1 but greater than 0, then it will be a decreasing exponential function. These are the increasing function. When if you increase x, then y increases. For three cases, for this one, and this one, if you increase x, y increases. So these are increasing exponential function. However, when y equal b to the power minus x, when b power will be negative, then this one we can write 1 by b to the power x, or we can write 1 by b whole to the power x. So you see, these are the graphs 1 by 10 whole to the power x. These are the decreasing exponential function. When base will be 0 to 1, then those graphs will be decreasing graphs. You can plot those graphs point by point. 1 by 10 whole to the power x will be just symmetric to this one. This graph and this graph, they are symmetric to the y-axis, above and below this point. And 3 to the power x and 1 by 3 to the power x, they are symmetric to the y-axis. 2 to the power x and 1 by 2 to the power x, symmetric to the y-axis. But this one, and this one, they are called decreasing exponential function. These are decreasing, decreasing exponential function, and these are the increasing exponential function. Increasing exponential function. Why increasing? Because y increases when x increases, and here when y decreases if you increase x. So that's all in this video, and in my next video I will discuss logarithmic function. Thank you very much for your watching.